Good morning or good afternoon, everyone, depending on where in the world you are. We're gonna get started in a couple of minutes. Just give everyone a chance to join us in the so start the recording. Okay. Hello, everybody, and welcome to today's webinar on 4 key DevOps principles for cross-platform database teams. The principles that we're going to talk about today are applicable to all database platforms, but hopefully, as you are all aware, our primary focus is going to be on SQL Server and Oracle. We'll start off by a couple of slides talking about DevOps, followed by product demos of how Redgate can help you implement the DevOps principles that we're going to talk about today across your databases. So just a couple of housekeeping items. So everyone will be on mute, but if you have any questions, please feel free to post those on the GoToWebinar panel, and we'll try our best to answer as many of those as possible during our QA session at the end. So my name is Arne Eskandari, and I'm the head of pre-sales engineering for the North America region here in Redgate. I've been with the company for just over 7 years, and as part of my role, I've helped hundreds of organizations across different industries implement DevOps best practices and streamline their delivery process across their applications and databases. So here's my contact information, so please feel free to reach out if you have any questions. Now, for those of you who are new to Redgate, we've been in the business for just over 18 years, specializing in solutions mainly for SQL Server and Oracle platforms, helping developers and DBAs improve their practices around database change management, delivery of changes, data compliance, and monitoring. We're also pretty big on supporting the community. We have over 2 million active users on our SQL Server Central and SimpleTalk websites, which has now become the Redgate hub. And we also sponsor a lot of free events such as SQL Saturdays and different users and DevOps groups. Now, since our topic today is DevOps, I'd like you to also draw your attention to Redgate's number of product releases for past year here on this screen. As a software company, we really do practice what we preach. As you can see, we had total of 1,147 minor and major releases. And we've actually seen a significant uptake in this number over the past couple of years as a result of continuously improving our DevOps practices internally and being able to deliver value to our customers faster and more frequently. So what are we focusing on today? We'll quickly remind ourselves of what DevOps is and what it means in the context of databases. Then we move on to talking about the 4 principles that any database shop should follow in order to implement a successful DevOps pipeline. Starting with data masking, which is the key to having a compliant DevOps process for your databases, followed by the other 3 principles here, which are source controlling, continuous integration, and release management. Obviously, these are not just specific to databases, and a lot of you might already be following these principles on your app code. And so we're going to talk about how you can apply these principles to databases as well. And we'll finally wrap up our session with Q&A at the end. All right, so before we look at the first principles, let's make sure everyone's on the same page as to what DevOps is. Because if you ask 10 different people what DevOps is, you're going to get 10 different answers. Some might say DevOps is all about automation, or DevOps is about delivering more features, or some bad ones, such as DevOps is a team of engineers who know PowerShell. But here's the definition of DevOps from Microsoft's point of view that hopefully resonates with you all. So DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The key things to note here is the words people, process, and products. What this means is that you can't just go and buy some DevOps tool and say we're a DevOps shop now. Or if you're a database shop, you can't just sit your devs and DBAs next to each other and say, oh, we removed the walls between dev and ops, so we're doing DevOps. And it's not something that you can just implement once and be done with it, right? So it's actually a journey that requires continuous improvement in these 3 main areas. So again, people, process, and products to help you with DevOps. Having the right people and process is really the key to success of any DevOps initiative, and then the tooling really comes next. But today, our main area of focus is going to be on the principles and tooling that Redgate can help you with. The other important thing to note here is that we're talking about delivery of value. We're not talking about delivery of features or more code, because really the ultimate goal of any DevOps initiative should be to deliver more value to your customers quicker in order to stay ahead of your competition and be able to easily accommodate new market changes. Okay, so now let's talk about DevOps for databases. So hopefully by now we all understand the benefits of DevOps, and here we've highlighted some of them. One common trend that I see from working with different organizations is that most application teams have modernized their development and delivery process and have introduced automated testing, releases, but whereas development and release process around databases are still neglected. And most organizations still see the databases as a bottleneck to faster and more frequent delivery of software. In many organizations, DBAs are still spend majority of their time reviewing database change scripts that can take anywhere from hours to even days, depending on their release frequency. And in a lot of cases, they actually have to rework the database scripts multiple times until those scripts are considered as production ready. Part of this because databases are difficult to treat as code. There is a lot of pressure on DBAs to maintain the integrity and safety of their data in the databases, whereas in applications you don't have that problem. And so you can't just simply do a replace, like when it comes to doing the deployment. So you have to be really careful about what you're deploying to your production environment when it comes to databases. Another issue is that databases are not really stored as text, so you can't just easily go and source control your databases like you do for your application code and put those through an automated build and release process. So really the bottom line here is that we understand the challenges associated with modernizing development and delivery process for databases. And we believe that with the right process and tooling, you can definitely achieve a true DevOps process for databases, and that's what we're going to show you next. So we already said that DevOps is a broad concept, right, and requires the right culture, right people, but it's also about having the right processes and automation in place to replace a lot of the manual and repetitive tasks that are time-consuming and error-prone. So here on the screen, we have a typical change management pipeline for code that starts from the left, where we have developers making changes to code, committing their changes into source control, which is obviously one of the fundamental principles to a successful DevOps pipeline. And then later on, going into an automated build process when you're validating your changes, running your automated tests or your unit tests. And if all of those pass, then you package up your build and then go ahead and release that build to target environments in a systematic approach. So at Redgate, we believe that the same principle should be applied to databases without having to change much on what we're already doing with the app code. Therefore, the same techniques and steps should be taken, but of course with the addition of data and the DBAs to oversee the release management process, as you can see in this diagram here. Now, with databases, since they carry data and developers and testers are normally require some level of data in their dev environments for testing purposes. With that in mind, here's Redgate's preferred database DevOps process. So as you can see, it's less linear with the addition of monitoring, backups, and provisioning and masking, which is basically a major concern to a lot of organizations these days as far as data privacy and protection goes. So what we're saying here is that for shops where they're grabbing a copy of production for their development and test environments and they're refreshing the environments, you need to kind of provide, create a standardized process there where, as the data travels through downstream to your lower environments is masked and properly protected for development and testing purposes. So we're going to talk about that in more details in a little bit. So some of you might be familiar with Puppet's State of DevOps report. So given the importance of the database within these DevOps practices these days, Redgate for the past few years has done a similar report on state of database DevOps. And here are some results from those surveys that I would like to share with you all. So as you can see from this graph, the development practices you associate with DevOps, version control, automated deployments, and etc. are more commonplace in the application in comparison to databases. So what we'd like to do now is to run a quick poll to kind of get a feel of where everyone's at as far as these practices and whether or not you are already applying these in your database development. Okay, so give everyone a few seconds to go ahead and respond, and we'll share the results with you guys. Right, 75% voted. Almost there. Okay, I think we're good. So let's go ahead and close the poll here, and let's share the results real quick. So as you can see, so this is really good. So and it's funny because it's fairly consistent with the actual survey result that we see here. So again, 56% of you folks are already version controlling your databases, which is great, and 40% of you are already monitoring the performance of your SQL servers. Only 4% are automating their deployments on the database side, and 0% have continuous integration in place. Again, which is fairly common, and it's well aligned with what we see out there in the market. So this is great. That means we definitely have the right audience for our session today. So let's go ahead and hide this and continue with our a couple more slides here. So the same really applies to third-party tooling. So here you can see there is significantly more third-party tooling in place for the application and significantly less resources and tooling for those working on the databases. And this is particularly prevalent when you look at practices such as version control, deployments, and automated testing. And by the way, this is all from the State of DevOps Database DevOps report that Redgate runs every year. So another interesting finding is that we find that more and more developers are now required to work across both the database and the app code. So from the survey that we did, only 24% worked specifically with databases, but 76% worked with both database and application code. And this is another reason why it's now more important than ever to make sure that you're following a standardized process across both your databases and your application delivery, so that way they're consistent and streamlined. So I'd like to run another quick poll here just to get an idea of our audience today as far as whether you guys only work with databases or you actually work across both database and application code. So let's go ahead and run that poll here. Again, give everyone a few seconds to respond. Okay, so far it looks like it's 50-50. We have 50% of the audience who only work with databases, and about 50% who work with both application code and the databases. So looks like 88% voted. So we can go ahead and close it. All right, so let's see what the final result is. So it dropped down a bit. So as you guys can see, about 7% are only application developers. So hopefully you guys, after this, you'll see how you can, how easy it is to apply the same principles that you might be already applying to your application code to the databases. 38% only work with databases, and 55% work with both application code and databases. Perfect. All right, let's move on. So one final slide before we kind of move into the demo here. So in addition to more people working across both application and database, thanks to new development projects or mergers and acquisitions and a range of other business scenarios, organizations are now adopting more and more databases of various types. So DB Engine's ranking ranks database management system according to their popularity. And in today's webinar, we'll be discussing two of the most popular platforms in detail, which are SQL Server and Oracle. Okay, so the first principle that we want to talk about, which is very specific to databases, is data masking for compliance. Again, this has become a very hot topic as a result of all the the data breaches that we saw in 2017, as well as new data regulations coming in with GDPR, starting in May, and so the organizations are forced to kind of do a better job at protecting their data as a result. So this is what we'll start with, and what's interesting when it comes to databases is that from that same State of Database DevOps report, we found that 60% of people who responded, they use their production data in their lower environments for development, testing, and QA purposes. So I'd like to run another poll here real quick, just to kind of get an idea of what you guys do in your development environment for databases. So let's go ahead and start that poll and see what you guys, what kind of data you guys use for testing in your lower environments. Okay, so we can go ahead and stop the survey, and let's go ahead and share the results. So it looks like 29% they master data, which is great. 25% do it occasionally on an ad hoc basis, 18% do it very rarely, and 29% they don't master data in lower environments. So let's go ahead and talk about that in a bit more detail. So let's hide this and take a look at a demo of how Redgate can actually help you with that. So in our product portfolio, we have a couple of masking tools, one for SQL Server and one for Oracle. So when it comes to masking data, obviously when you work with data in lower environments in general, you want that data to be as realistic as possible. So when you're running your tests, you're kind of working with a realistic data that kind of matches production. But you also don't want it to be the actual real data from production, especially if you have sensitive data such as PII or PHI in your databases. So we provide a couple of tools here. So first of all, the databases that I'm working with. So here I have the SimpleTalk database, which is kind of the database that sits behind our SimpleTalk website. So we'll be working with this database for all of our demos today. And then on the Oracle side, we have a CRM database that we'll be working with. So let's go ahead and take a look at the SQL Server side of things first. So here I already have a data masking project open. So the way that our data masker works is that once you've identified where your sensitive data is in terms of what tables and columns, so for instance, if we look at our database here, we can see that our we have a table called contacts, which holds some sensitive data, some PII such as name, address, phone numbers, etc., and email. So what we've done here in our masking project is that we've created a set of rules that defines how we want to mask the data in this table. So there's different types of rules that you can apply to make sure that your data is as realistic as possible. So when you look at the test data, it just tastes and feels real, and you cannot tell the difference between that and the actual real data that comes from production. So the way that we do this is that we actually replace the data entirely in your dev environment on the tables and the columns that you've specified in your rules, as opposed to anonymize it using an algorithm that is that can be reverse engineered. So it's none of that. So we just simply take the already existing data in your lore environments, and we just apply the masks that you specify in the rules. So there are some common rules such as substitution, for example, where you just simply take some common PII or PHI and replace them with test data. So the test data is provided, or the fake data is provided by the tool itself. It simply goes ahead and replaces it. But normally substitution is not enough if you want to, keep your referential integrity in place, for example. So there's other synchronization rules, such as rules that you can use to synchronize data within the table itself, or you can use synchronization rules between tables. So if you're using the same data in different tables based on the primary key values or foreign keys, then you can apply synchronization rules across tables and even databases to make sure that your referential integrity is intact. So and then you can even create your own rules using SQL and commands. So it's very powerful in terms of giving you the flexibility to mask your data in any way you like. And the nice thing about this is that you can either run these masking sets manually through the UI, as you can see here, or you can run it automatically through a command line. So if you want to put together a process that is repeatable and consistent and reliable, you want to do it in an automated fashion as much as possible. So that way you're not relying on people to go ahead and run a masking set, for example. So this tool comes with a command line that you can either just integrate into your whatever your existing process is for provisioning, whether it's just backup and restore of a production database. You can apply the masking set as part of that same process in a job. Or if you have if you're using, for example, Redgate SQL clone to provision copies of your databases to lower environments, then this is already integrated into our SQL clone tool. So you can just run a masking set as part of the cloning process. So let's go ahead and take a look at the rules that we already defined for this context table here. So here I have a couple of rules. One is substitution. So I'm simply substituting some of those common PII that you see in the table, such as full name, phone number, address, country code, and dates and photos. So the tool already provides you with a different sets of data that you can just simply select and simply replace your real data with whatever is provided by the tool. So the tool also provides you have the option to specify a where clause. So for instance, if you have a column that defines the gender, such as a title column, then you can specify a where clause and say, hey, for titles of Sir or Mr., use a male name as opposed to just any name, or female, and then just use the opposite for all the other records. So there is a lot of flexibility here as far as making sure that your data really is real and tastes real. So substitution is fairly straightforward, and then we're doing a synchronization rule here for email, right? So again, you want the email to look realistic. So when you're replacing your names in your table, you want the email to match that, whatever name that we replace the real data with. So here we're just simply running a substring command or statement in SQL to take the first name and last name that we've now replaced with or masked, and just create a fake email address out of that. So that's why we're using the this synchronization rule here. So now let's go ahead and run our masking set against our table here, or our database. So here you can see it's now running our steps, and it's complete. So I only have 10 records in my table. So it went ahead and masked all of that. So let's go ahead and take a look at the data real quick in this table. So here we can see is the test data or the fake data that we've replaced the real data with. And everything again just looks and tastes real, including the email address and everything else. Okay, you can do the exact same thing on the Oracle side of things. So if I go to my Oracle schema here and take a look at my tables, we have a similar table here on the Oracle side called contacts, and this table hold similar information such as name, address, phone numbers, and things like that. So I've got a similar kind of rule set up here on the Oracle side. Again, I'm doing a substitution for anything that can be simply substituted by a test data or a fake data, including name, numbers, and address. And I'm doing the same thing for email, where I'm replacing it with a SQL statement to take whatever the fake data is for first name and last name and generate an email address out of that. And I can go ahead and do the exact same thing on the Oracle side. I can run my masking set. Okay, and look at our stats. So we had a bit more data on the Oracle side, so we had 100 records, and you can see that all of the rows that we had to process got processed successfully, so we know that we haven't missed any records out from the rules that we had specified for our masking. And we can go ahead and take a look at the data real quick here as well. And here's the mask data that we just replaced using Data Masker. Okay, great. So hopefully everyone got a good idea of how our masking works and how you can use these tools across both your SQL Server and Oracle platforms to mask your sensitive data. Again, both of these tools can be ran from a command line, so you can automate the process if you need to. All right, let's go back to our slides. The next thing we talked about as far as our 4 principles is source controlling. So version controlling or source controlling database changes is really the first step to a better database development practices. You should already be doing this, even if you're not looking at implementing DevOps in order to ensure database development teams can communicate their changes with others in the team and always have a version to roll back to if required and maintain a solid audit trail. Now, this can become a challenge if whatever tool you decide to use enforces strict, unfamiliar procedures and asks database developers or full stack developers to work in a different way from what they do on the application code side, right? So especially as we saw earlier that more and more people are working across both, the key is to really integrate with existing version control systems like Git, like TFS, or any other source control system that you might be using, and allow developers to continue working in whatever IDE that they like, and go ahead and commit their changes easily into their source control system. So let's go ahead and take a look at how Redgate can help with this, again, across both SQL Server and Oracle environments. So let's take a look at the demo. So we'll be working with these exact same databases that we just saw. So here's my development database for the SimpleTalk database. So I'm going to be making a couple of changes here against my development environment. So let's go ahead and make some changes. So I'm going to make a couple of changes. So let's modify an existing object. Okay, so here we have select star from, which is bad practice. So let's replace that with some columns. And let's make a table change as well. So let's modify that same table that we masked earlier on. Let's add a Twitter handle, for example. Okay, so made my changes. Now, typically, if you as a database developer are following a manual process, you would have to actually save up the scripts for these changes that you make. Now, it's very common for developers who are doing things manually to be working with a ticketing system, for example, where they have to, submit your scripts through a ticketing system to either a DBA team or an ops team, where they review those scripts and then execute those against target environments. Or you just basically save off your scripts manually as a developer, put it in source control, and then kind of deploy those out to your target environments later. The problem with that is, first of all, it's time consuming. As a developer, you have to always remember to save your scripts off. It's error prone because you can easily forget changes, or you can even overwrite some existing changes with new changes if you're kind of modifying the same existing file. So with this approach, you don't actually need to do that. So the changes that I made, I can just simply right click on my database and say commit changes to source control. And here it will show me the changes that I've made against the development environment. So I'm using a demo VM, and it's a bit slow, so apologies for the slight delay here. But one question from Scott, one of our attendees here, is the question is, do you recommend branching merging in database source control? So a really good question. So branching and merging obviously is used when you have you're either working on different features that are going out on different timelines, or if you're working with a database that is being touched by different applications, and those applications have different release timelines going into target environments. So if you have any of those two cases where you need to cherry pick changes from your development environment and in order to push those out to your target environments, then branching is really a good idea. And especially if you're using a source control like system like Git, which is actually what I'm using here. So you can see here it shows my current branch that I'm on in my Git repository, and I'm doing the same thing on the Oracle side of things. So I can easily switch branches and merge branches when these changes are ready to go. So if you have to cherry pick changes or specify a set of changes to deploy to target environments, it's always a good idea to branch those out, make your changes, and then when those changes are ready, then you just simply merge the branch into your master branch or whatever branch it is that you want to deploy from. So here's the changes that I made. So you can see the context table that was modified. So here at the bottom, I can actually see the difference between what's already in source control and what I modified. So we added the Twitter handle as a column to this table here. And we also modified a store procedure. So we can see, again, what we've changed here at the bottom. Another thing you'll notice here is that we're not actually putting the actual change script. Like I'm not putting the alter procedure or the alter table scripts in here. What we're doing is that we're storing the definition of your table in source control, so that way it kind of follows the same principles and process as what you do on the application code side of things. And this gives you a couple of benefits. One is that you can easily track what kind of changes you've made to any given object. So you can look at the history of individual objects and see how those objects have evolved and by which developers. And that you can then rely on the compare engine from Redgate on both the SQL Server side and the Oracle side to then translate these into change scripts and execute those against your target environments as part of your release process. So I'm going to go ahead and select my changes here, and I'm going to write a meaningful comment. So we added a column for Twitter handle to contacts and altered the PRC get contacts to replace the star. All right, let's go ahead and commit that into our master branch here, and because we're working with Git, obviously you always commit your changes locally into a working folder, and then you have to push those out to a target environment. So I'm going to go ahead and do the same thing on the Oracle side. So I'm going to go ahead and make a couple of changes, similar changes to what we did on the SQL Server side. So I'm going to go ahead and add a column to this. Looks like my VM is thinking, so let's give it a couple of seconds here. Hopefully, well, that explains why. So, okay, so let's go ahead and make some modifications here. Okay, so let's call this, let's do the same thing. Let's call this Twitter handle. Okay, and I'm going to also modify a a procedure here as well. Okay, so made a couple of changes. Just like the SQL Server side of things, I can go ahead and check in my changes using source control for Oracle. So the tools that we're looking at are actually separate. So we have a separate set of tools on the Oracle side and separate set of tools on the SQL Server side. So here we're using the source control for Oracle. So as you can see, it's picked up on the changes that I made in my development environment. So again, if you look at the context table, we can see that a new column has been added, and the same thing with the store procedure here and what we've actually modified. So let's go ahead and write our comment here. Just to keep it short, since it's just a demo, I'm just going to say made some changes. And go ahead and check it in. Okay, so once you check in your changes, then you can always see the history of changes that you make. So if I go to the history tab here, I can see all the commits that I've made into my Git repository. You can see who made those changes, what kind of changes were made, and how they were different from the previous version to the current version that you're looking at. And if you're working with shared databases, which is actually fairly common, then you can lock objects as well. So you can go in and specify certain objects that you want to lock, work with those objects, and when you're done, then you can unlock, or anyone else can unlock them as well. So it's more of a communication tool that, hey, I'm working with this object, don't make changes to it while I'm making my changes. The same thing can be done on the SQL Server side of things. So if I, oops, sorry, I forgot to push. Okay, and the same thing can be done in SQL Server. So you can go to this locking tab here to lock objects that you're working with, And again, this only applies to shared development environments. So if you have a shared development database, you can utilize some of these features here to prevent developers from stepping on each other's feet. All right, so hopefully you've now got a good idea of how we can help with source controlling and how easy it is to source control your changes. Again, as a developer, you no longer need to save any scripts off, so it's less error prone, and it's a lot easier and saves you a lot of time as a developer and a lot of headache as well. So let's go back to our slides and talk about the third principle, which was continuous integration. So continuous integration, as hopefully most of you are aware, is basically the process of validating your changes that you check into source control, either by running a set of automated tests or unit tests or code analysis tests to make sure that your application or your code or your database can be compiled successfully from scratch. It's very common in the databases world for you to have a lot of invalid objects that are no longer being referenced by your application code, right? And that's actually a technical debt that you just keep accumulating in your database. And it gets to the point where your database is no longer buildable, meaning that you cannot build that database from scratch if you wanted to, except, just doing a backup and restore, right? So a continuous integration process can actually help you with that. It can help you keep your database clean, make sure that all your objects are still valid, making sure that there is no SQL Server compilation or syntax errors with the scripts that you've put into source control. And if all of that is good, then that means you can get a successful build and move on to then releasing your changes to your target environment. So best practice is that if your continuous integration or if your build process fails, then you shouldn't continue to the release side of things. You should take a look at why it failed, make the fixes, and then commit those into source control again and run a new build. And if that build passes, then you have the green light to go ahead and deploy to your target environment. So it requires a bit of discipline and standardized process in order for this to work properly. And another thing is that best IT performers are now reducing the amount of manual work. So high performance automates significantly more of their configuration management, testing, deployments, their change approval processes. And as a result of that, from that same State of DevOps report from Puppet, we saw that 30% people are doing 30% more of their configuration management through automation, 27% more testing, 30% more automated deployments, and 27% more change approval processes. So this really does help you solidify your release pipeline and make sure that only things that are valid and are not breaking anything get past this point and then get deployed to target environments. The other important thing to note here is that, again, you should be able to use whatever build system that you might already be using on the application code side for your database. So whether you're using Jenkins, TeamCity, TFS, you name it, you should be able to just stick to those tools and be able to build a pipeline for your database alongside your application code. And that's what we're going to show you all next. So let's hop back into our databases. So the build system that I'm using today is TeamCity. So let's go ahead and take a look at our TeamCity here. As you can see here, we have a couple of projects, one for the CRM schema on the Oracle side and one for SimpleTalk on the SQL Server side. So we have a couple of solutions here. One is called DLM Automation, which is on the SQL Server side of things. It provides you with a set of PowerShell commandlets to allow you to define your build and release process for your databases in, again, whatever build or release management system it is that you want to use. And then the same thing on the Oracle side of things, which is called the deployment suite for Oracle, which provides you with the command line of our comparison engine alongside the source control tool that you saw earlier to allow you to kind of achieve the same thing on the Oracle side of things. So what we're really doing here as part of the build process is that we're rebuilding the database schema on a temporary database to make sure that all your objects are still valid. So it's very common for you to, for example, make a change to a table and break a bunch of stored procedures that are using that table. So this will actually prevent that. So if you have now invalid stored procedures as a result of a change that you've made to a table, then this build should fail, and it will tell you where it failed, so you can go back and make those additional modifications to those stored procedures to make sure that they're valid, and then kind of continue with the rest of the process here. So that's kind of the primary focus here, is that to make sure that your database can be built from scratch as far as schema is concerned. The other thing that I forgot to mention is that you can treat your static data or your lookup data like code too. So in both SQL Server and Oracle, you actually have the option to link and unlink static data to source control. So here you have the option to link static data. This is basically referring to lookup tables or data that is consistent between your environments all the way to production. So if it's a good idea to source control data changes to those tables and be able to promote those data changes alongside your schema changes as part of the same process. And it's the exact same thing on the Oracle side. So you can go ahead and add static data to your project. So you can specify which tables you want to source control in terms of data. And from that point onward, any data changes made to those tables will be tracked by the tool and will be checked into source control and later on deployed as part of the same release pipeline. Again, just to remind you, everyone, you can post your questions in the webinar panel here. So if you have any questions, please do post them there, and we'll get to those in a little bit as part of our Q&A session. All right, let's go back to our build here, see where we're at. I wish I had a beefier VM here, so it looks like it's it's not utilizing almost all the resources on both CPU and memory, so that's why it's taking a bit longer than it should. If we were on a build server, then all of our steps would have been complete by now. So. So I guess what we're waiting here, let's talk a little bit more about the configuration side of things. So again, it's fairly simple to get up and running with these tools. For some build systems, we have plugins, like for TeamCity, we have plugins that you can install on TeamCity. So instead of having to work with PowerShell or command line, you can just simply use our plugins to define your build and release your release steps. So if you take a look at my build steps here, you can see that we're basically using our plugins here. So there's a plugin called Redgate DLM Automation on the SQL Server side of things. So it provides you with the simple UI where you can just go in and define where your database code is sitting, as well as what temporary database you want to use for the build validation, whether you want to use local DB or if you want to use a specific instance of SQL Server, such as your dev instance or any other instances. So again, it's fairly straightforward, as you can see, to specify it. So when the build completes, it needs to generate an artifact, right? So for those of you who are familiar with build systems and build jobs in general, there is normally an output as a result of successful builds. So our output in this case is a NuGet package, which is a Microsoft technology. It's just like a zip file, but it accepts some additional metadata such as version number and names and IDs and things like that. So if our builds are successful on both ends, we go ahead and create a NuGet package here as part of our projects. And those NuGet packages is what we'll be using later on to promote to our changes to target environments. So we're going to take a look at that in a bit more details in a little bit. Okay, so it looks like our build on the SQL Server side is almost complete. So you can see our builds were all successful. So the Oracle one ran 9 minutes ago. It ran first, completed, and our build on the SQL Server side also completed. Another thing you notice here is now it's trying to deploy to our environment. So we're doing this as part of Octopus Deploy. So Octopus Deploy is a release management tool, and here you can see our deployment process has started. So while that's running, let's just quickly hop back onto our slides and talk a bit more about the release management. So, which is the fourth principle that we talked about. So, it's very important to again have a standardized release process for your databases. And in most of most cases, you might already have a process like this already set up for your application code. So you should be able to easily integrate the database into that same process. Again, as I mentioned earlier on, it's very common for database shops to use like ticketing systems to submit tickets to DBAs, and those ticketing systems is basically what we use to have an audit trail of what we've deployed to target environments. And that obviously, as you all know, it's very time consuming, right? From the moment you submit a ticket to the moment that ticket gets approved or gets looked at by a DBA, it could take hours, in some cases days, depending on how many changes or how big that release is, right? So there is a lot of time wasted as a result of that. So the idea here is to replace that manual time-consuming slow process with something more standardized, where you're using a release management tool that replaces the ticketing system to keep track of what releases you've done to what environment. You can easily version your releases. You can specify what goes out as part of a given release and what that process looks like. You can also do gated releases, where you can do a review of changes, make sure everything looks good, and then move on to a given environment, and all of that good stuff. So there's different tools out there that on the release management side of things. Octopus Deploy is one of the top ones. TFS does a brilliant job at that as well. So, and there's some other release management tools as well that can be used. Jenkins has the Jenkins pipeline, for example, that you can orchestrate your release process. So all of these tools can be used for databases as well, if using the Redgate command line. So let's go ahead and take a look at what we're doing here on the database side of things. So let's hop back on our demo. Okay, so as you can see here, it's kind of already triggered the deployment to our integration environment. So the process that we've set up here is that if our build succeeds, then just go ahead and start the deployment to our integration environment. The integration environment really acts as that shared development environment. So if your developers have a dedicated database that they're working with, then that integration environment is the shared database that everyone's changes kind of goes into first, and then from there it gets promoted out to your target environments. So what we're doing here is that we're utilizing the engine of our compare engines on both the Oracle side of things and the SQL Server side of things. So a lot of you might already be familiar with our SQL compare tool or our schema compare tool for Oracle. We're using the exact same engine in this process. So we're utilizing the command line of those tools to run a comparison between the state of our database. So if you take a look at my artifacts from the builds while this is running. So if you go to our successful build here and look at our artifacts, so here you'll see our NuGet package that gets generated as part of the build process. And if you take a look inside that NuGet package, we can see our database schema, and you can see all the objects that we have in our that came from our source control. So this is basically wrapping up the whole database schema as a package, and then our compare engine compares this state from the package to the state of whatever your target environment it is that you're deploying to. And based on that comparison, it then generates that Delta script or that migration script that you need to apply to your target environments. So if we go ahead and take a look at our deployment here real quick, you can see our deployment was successful. So if I go and take a look at, and you can see the simple talk deployment has now started on the SQL Server side. So while that's running, so we just ran our deployment on the CRM schema on the Oracle side. So to the integration environment. So if I go to the folder where we store our artifacts, and here's the release 5021 that we just completed. So here's that update script that the compare engine has generated for those changes that it detected or the differences that it found between our NuGet package and the target environment. So as you can see, it's altering the table to add that Twitter handle column that we added, and then it's creating or replacing the store procedure that we modified. So again, I don't need to worry about the ordering of changes because the compare engine is intelligent enough to figure out the ordering, and I don't need to save anything as a developer or worry about, oh, did I get my ordering right for my scripts or any of that. So again, this can help save a lot of time. And we're doing the exact same thing on the SQL Server side of things here. So if you go back to our project on the SQL Server side, so here you can see the deployment is now running to my integration environment. So we won't have time to push the changes all the way out to production, but it's going through the same process for every single one of these environments. As I said, you can introduce a review step between these environments. So once a deployment to an environment is complete, you can get someone to review it and approve it before it goes on to another environment. So just because the process is automated doesn't mean that you have no control over that. You can actually introduce those gated reviews wherever you want to as part of the process and standardize it. So since we only have 2 minutes, I'd like to kind of look at some questions here. So again, if you have any questions, please do post them here in the webinar panel. Okay, so one of the questions is, how does your tool handle cross-database dependencies? So that's a really good question. So I'm sure a lot of you guys work with databases that have dependencies across different databases, right? So the way that works is that you would still be working with each database individually, making your changes to the given database. But when you're doing your build, you would need to make sure that whatever SQL Server instance that you're running the build on has those dependencies available. So a lot of our customers or our end users, do their builds against their dev environment because any dependent databases that they need are already available on their dev environment. So they run the build in that environment, so you can also validate any objects that are being referenced as part of the objects of that database that is building. And then once that's validated, then you just go ahead and deploy each database individually. So each database will have its own package, its own source control state, and we will go ahead and compare those databases individually and deploy those out to the target. Another question from Scott Price is that will we be able to download the presentation? Yes, so really good question. So this will be available. The recording of this webinar will be available online. So as soon as that becomes available, we'll send you all an email, and we can also share the presentation with you guys as well. So unfortunately, we hit our hour here. So again, if there is any questions, feel free to reach out. So let me just quickly show you my contact information again. just in case if you guys have any questions. So you can reach me by email. And if you have any other questions on the technical side or implementation side or anything else, just let us know. We'd be more than happy to help. Otherwise, thanks everyone for your time today. Hope you found this really useful. And I also hope that you have a good rest of the day. Thank you.